when we use implicit differentiation to find the derivative of y with respect to x, first of all, when we see dy over dx, we know that y is a function of x. So that is the first thing we write. So y is a function of x. And after that, since we want derivative with respect to x, we're going to take derivative with respect to x on both sides. So we will differentiate with respect to x on both sides. So we take derivative with respect to x on both sides. Right. And of course the derivative of a sum is the sum of derivative. We can write as 2 and then d over dx of x to the fifth and then this you can just write derivative of 7y to the fifth, or 7 times the derivative of y to the fifth. I will just give d over dx. I could put the 7 outside or inside, doesn't matter. Let's just keep it inside. I can put the 2 inside here as well. And then the other side, the derivative. I said I just keep the constant inside the derivative. It's fine. Now, derivative of x to the fifth, this is easy. That's 4x, 5x to the fourth power. So we have 2 times 5x to the fourth power. That's easy. Now this, the difference between this one and this one, this has the y as the variable. So if we look at this, we have derivative with respect to x. I'm going to put that over here. Derivative with respect to x of 7y to the fifth. I just write 7 times something to the fifth power. Because y is a function of x, instead of y, I just keep a function of x in the parentheses. The derivative of this is power rule. 5 times 7, that would be 35, parentheses to the fourth power. And then we have the derivative of the parentheses. So we do that if we have y inside the parentheses. So that's what we have. Remember, y is a function of x, so by chain rule we have to have this part. And finally we have 35y to the fourth power, derivative of y. I will write this to be more specific, derivative of y with respect to x. So that's what we have. So we have 35y to the fourth power, and then dy over dx. Right. So that is on this side. On this side, when we take derivative with respect to x, now this is very important. We have x is a function of x, obviously, so we can say this is a function of x. and then y is a function of x as well. So we have another function of x. So two functions of x multiplied together, the derivative of that, it must be a chain rule. Right. So u will let equal to 9x. Derivative of it is 9. V is equal to y. Derivative is just y prime. We take derivative. Or we just say this, dv over dx, or v prime is equal to dy over dx. And will be just that. And that's what we want. So we're going to put that back in u prime v, and then plus u v prime. The product rule, u prime v plus u v prime. Right. And then u v prime. Put this in red. Right. So if we have y in it, there should be a chain rule, and y is a function of x. So that's the product rule. Right. Simplify this. We have 10x to the 4th power plus 35y to the 4th power dy over dx equal to 9y plus 9x dy over dx. Now we just solve for dy over dx, so we move everything on the other side. If this does not have dy over dx, so minus 10x to the other side, 10x to the 4th power on both sides, and then minus 9x dy over dx. So do that. We will have everything with dy over dx on one side and everything else on the other side. So on this side we have 35y to the 4th power dy over dx minus 9x dy over dx equal to 9y minus 10x to the 4th power. Right. The rest is simple. We factor out dy over dx and then we solve for it. So factor out dy over dx. Inside we will have 35y to the 4th power minus 9x equal to 9y minus 10x to the 4th power, and then divide by the parentheses. So that's what we have. So dy over dx equal to 9y minus 10x to the 4th power 35y to the 4th power minus 9x. So that's what we have.